rotary motor.
I remember the first time I looked in a biochemistry textbook and I saw a drawing of something called a Bacterium Flagellum with all of its parts in all of its glory. It had a propeller and the hook region and the drive shaft and the motor. And I looked at that and I said, that's an outboard motor. That's designed. You know, that's no chance assemblage of parts.
B's reaction was not surprising, especially when the bacterioflagellar motor is animated and magnified more than 50,000 times to display the details of its construction and operation.
Howard Berg at Harvard has labeled it the most efficient machine in the universe. These machines, some of them are running at 100,000 RPMs and are hardwired into a signal transduction or sensory mechanism so that it's getting feedback from the environment.
It's got some tail proteins which act as the propeller. When the flagellum rotates, these push against the water and therefore push the bacterium forward. And the motor uses a flow of acid from outside of the cell to the inside of the cell to power the turning.
The bacterial flagellum has 2 gears, forward and reverse, water-cooled, proton motive force. It has a stator, it has a rotor, it has a U-joint, it has a drive shaft, it has a propeller. It's not convenient that we give them these names. That's truly their function.
In all, about 40 different protein parts are required to build a flagellar motor. Since its discovery, biologists have tried to understand how a machine of such superb design could have arisen gradually, without foresight or plan, through the biological pathway Darwin envisioned.